what are we going to, expect out of the platform?
Amazon originally built all these services for themselves to make a retail store online.
Most intriguing part of technologies these days is that how easy it has become for professionals.
Experts don't know how they do what they do.
Welcome to the BIM Student Podcast. In this podcast, we talk to leaders, followers, innovators, and adopters from our AEC industry. Like a student, I ask questions that we all wanted to ask on our digital transformation journey, but never actually did. I explore concept, products, ideas, and future possibilities in digital transformation space. Each week, I meet with an amazing guest from the industry. I look forward to learn something new, share new experiences, thoughts, and opinions, and how to make BIM journey better for everybody across the board.
In today's episode, I will be talking to Anthony Hawk. Anthony is a COO at Hypar. He believes in improving built environment through better tools for architectural design, engineering, construction, and facility operations. And what is Hypar? Let's talk to Anthony and find out. Welcome to the podcast, Anthony. Thank you so much for taking the time.
Thanks. Very happy to be here.
I have been looking into a lot of new technologies, and I have seen one of the most intriguing part of technologies these days is that how easy it has become for professionals to automate stuff. And I looked at Hypar, I was blown away. But I want you to introduce yourself and Hypar and what are we going to, expect out of the platform?
Sure. So I'm Anthony Hawk. I'm one of the two co-founders and the COO of Hypar. We have a cloud platform for generative design, which means a set of technologies that people can use to build applications, including us. A really good analogy for this is Amazon Web Services. I think everybody listening knows that, Amazon originally built all these services for themselves to make a retail store online, first to sell books, then to sell everything. What they found afterwards, of course, having accomplished that, is that these kind of services might be useful externally to other people building other types of things. And so my co-founder, Ian Keogh, and I thought of was, what if you could make services that were very specific to AEC and help people move their expertise online for worldwide distribution. And this, boils down to writing small programs that accomplish some task. But one of the things we did was, in contrary to our previous experience in software companies, we decided to make all our data open source and extensible. So the upshot is that much like how Amazon services all tend to work to one another, on our platform, people can make their own services, but they can still talk to all the services anybody else has put on there. So we're essentially trying to create an ecosystem of worldwide AEC expertise that people can mix and match into applications for their needs.
Okay. Having said that, you mean that if somebody wants to explore the generative design and has no knowledge of Dynamo or scripting, they can use Hypar?
Yeah. And one of the things we've been doing lately is, for the first couple of years of the life of the company, we started in almost exactly 3 years ago now in 2018. We thought it was enough to sort of show people tools and say, go. And then we realized that we really needed to start showing people what was possible on the platform. And so one of the applications we've built on top of Hypar is something we call Hyperspace, which at the moment is for office planning. And we're going to be extending into other sectors. In fact, for example, yesterday, a new partner of ours called Foresight Digital, who have a product called Fast Plan for healthcare planning. They just announced a partnership with us because at the end of the use of their software, you have a healthcare program, and we help them realize that as an actual, geometric healthcare facility. So somebody who wants to come to Hypar, there's a number of things that you can kind of drag and drop and sort of assemble what we call a workflow and produce any one of a variety of things. An office building, office plan with Hyperspace. We have customers who do piping. We have customers who do structure. And all of these things can come together as a building design. So we have both this kind of, raw, you're doing Grasshopper, you're writing C# code, and you can make something completely custom. But all of those things can be dragged and dropped into an application by somebody who doesn't have that coding experience and, hopefully come up with some good decisions about their building.
Okay, so like yesterday, when I was looking at the platform and before that, I could see that every time we get into the platform, we find new workflows in there.
Mm-hmm.
So which means that both the user and you as the service provider, both of us can create our own workflows.
That is the intent of platform.
Okay. And it can, and like I said, we don't need to know Dynamo or any other visual or a regular programming language for that. How amazing is that for somebody like me who comes from architectural background, who was never taught coding, who was never even taught how to think like a programmer, but we know what we want out of our design or what our clients want out of our design. So this is something that attracts me the most. Now, just a little bit of background here. I know you have a background with Autodesk, and Autodesk really is now pushing into whole generative design with Dynamo, Grasshoppers of the world, and other visual programming languages. Do you think programs like Hypar, and there are a couple more, but I mean, what I found most interesting about Hypar is that the ease of use, I would say, like it's not rocket science. It solves a problem, but it's not rocket science.
So my partner Ian Keogh invented Dynamo while he was at Borough Happold. And because another piece of software he wrote called GoBIM was acquired by a company called Vela Systems, he joined Vela Systems. Vela Systems was acquired by Autodesk, and that became BIM 360. And GoBIM became BIM 360 Field. Autodesk, with this kind of open source project that Ian created called Dynamo, Autodesk decided to take that and turn it into a product. Now, both of us, because I ran Revit product management for about 8 years at Autodesk, so of course I had a lot to do with Dynamo as well. One of the things we found is that there's certainly an appetite in the market for these kind of visual programming tools. Obviously, they're quite popular. There is also a finite number of those people as compared to a much larger number of people who actually need to make intelligent decisions about buildings. And so there's a gap there, and we're trying to help fill that, because what we see, and I'm happy to accept Autodesk's numbers around how many buildings we need to complete every single day to 2050, and that number, as stated by them, is 13,000 buildings every single day just to maintain our current standard of living worldwide, which frankly is terrible, right? Still, for most people on Earth, right? And so if we don't scale up design and engineering expertise somehow, what we're looking at in the future is a steady degradation of the built environment, because the buildings that are going to go up are going to be more and more devoid of expertise that could make them better. And plus, as even, the American Institute of Architecture will tell you, architects in traditional firms contribute to about 5% of the designs going up. So we've already got a bunch of professionals in architecture who are serving a very narrow economic and very high economic stratum, and who are pulling kind of a comet tail of professionals behind them. Meanwhile, there's 95% of the buildings are going up in without traditional architecture firms' involvement, although architects are involved, they have to be. And the question is, can we help make all of those buildings better by making the expertise to make better buildings more readily available to people who will never, ever hire a consultant? And this is one of the things that we say to professional firms, because they look at some of the automation we offer, and much as when Revit was first hitting the market, people started saying, oh, this will take my job. Like, no, it's not going to take your job. It's going to scale up what you can do because you need to contribute all around the world, and you can't. No one in Bangalore is going to call you, to say, hey, can you come do my house or do my project? But they might use the expertise you have up on Hypar to make a decision and get you a micropayment. And since you're getting zero from those people right now, it's all upside. So we have a vision of changing the AEC industry for the better, in that we want to make this very important critical expertise that we all depend on in the built environment widely available, and then allow the humans to concentrate on the difficult, non-automatable problems and, frankly, the art of what they do. Because I don't care how bombastic you want to be about architecture, when you're building a K through 12 school, 90% of it is exactly like the last school you made. And either you have a special theater or a great atrium, or there's a special sports facility or something that's important to that school. And that's where all the money is going. And that's fine. We don't have to make every single room an art experience. We can, however, make those experiences the best they can possibly be by encoding best practices.
Okay. I mean, I had so many questions, but just listening to you, I just went into a different thought process. Why did you keep your platform an open source platform? What is the reason behind this?
Yeah, I should draw a distinction. The platform itself is not open source, and there's actually more of a philosophical than financial reason behind that, which I'll explain in a second. The data format is open source, and actually most of the things we build on Hypar, we also open source. Really, the only time we don't do that is when we do contracted work for a firm that wants to keep their work private. So the reason, this was a repeated discussion between Ian and I, started the company, of should we just open source this thing? As, for example, Speckle has. I'll give a shout out to some friends of ours. And the reason we have not is we have been convinced that if we did that, the AEC industry is so, let us say, cautious about sharing that what we would expect to happen is people would take the open source platform, put it on a server inside their data centers, and no one would ever know what they did with it. And it might help those firms individually, but they're not going to move the profession forward that way. So even though we have all the capabilities for somebody to keep something private to themselves, to their organization, to 5 friends they like, or whatever they want to do as far as distribution of what they make, we made sure that they always had the option to expose that publicly. And upcoming, within a couple of months, expose that publicly for money, if they like, to start achieving that idea of getting micropayments for your expertise wherever it goes. So we have a certain philosophy that actually is born out of both Ian and I and our CTO, Matt Campbell, having come out of Autodesk, because all of us have had a lot of visibility into a lot of different types of firms throughout AEC. And, for myself, since I used to be on the large firm roundtable before I joined Autodesk for longer than the 10 years I was at Autodesk. And what was a consistent experience is we would visit, one firm in the morning who would show us some unique differentiating technology that they were working on, have lunch, go down the street to another firm, and see the exact same differentiating technology that they were working on, because they all talk to each other. People move firm to firm all the time. They carry what's in their heads. And all you need to do is tell somebody that the firm down the street has a application that they made to study zoning compliance in New York City. And now that they know it's possible, if they have the resources, they'll make one, right? And so we actually think that it's pretty rare that differentiating technology grows up in the professional environment. We have seen it in some very large firms, mostly involving middleware. But for the most part, there is kind of a joke that we used to use at the beginning where it's like there was a period, probably going on almost 10 years now, that everybody had a Stadium Bowl configurator in Grasshopper. It was kind of like the thing you did to show that you knew what you were doing. And one of the questions that Ian and I asked each other, like when we found one of the good ones, is why was there ever 2 of these or more of them? Because one of the ones we found was very, very good. Why didn't that become a project that other people could contribute to? And there are a lot of reasons. There's some of this culture of looking for market differentiators, and some of it is just there's mechanically there was no way to share these things other than things like, maybe food for Rhino or just sharing the script. So one of the things that we did on the platform is when you make something, people can use it, but they don't have to understand how it works, and they can't necessarily replicate it unless you want to open source it, which does not apply to something like Dynamo or Grasshopper. If you shared it, it's shared. The end. Like, everybody can look at its guts. And so understanding that dynamic in the industry, we wanted to make the experience of using software very much how people work on projects, which is, I get a package. I have a past as an architect that people don't know, but I get a package from the structural engineer. I don't know how they made that. I don't know how they made their decisions. I just have the product. That's what happens on Hypar. You don't necessarily get the how-to, but you get the result, and you can check the result. So very much in favor of community projects, because ultimately buildings are always community projects, and no one seems to have a hesitation about sharing their expertise around to achieve that. So what we're asking the industry is to go one step farther. Don't just improve a building, improve the industry, improve how we do things, because we've been doing them the same way for 5 or 6 centuries. And the needs that we have now are not going to be satisfied by doing them in the way we've been doing it for centuries, because our needs are becoming unique with large populations, climate change, logistical challenges. I mean, we can all add them up in our heads, right? That we're in a different order, in the same way that about 50 years ago, there were predictions that, the Earth was pretty quickly going to sink under overpopulation because there wasn't enough food to go around. Meanwhile, the Green Revolution happened, right? And there's enough food to go around. It's very poorly distributed, but there's enough. Right. And so we're in the same state right now with building. There's a huge demand, especially with things like urbanization of the population, for more and more of the built environment. And we have a limited resource of expertise to do that right. And we don't have time to produce that in the old-fashioned way by just trying to mint more and more architects and engineers in construction. We need something else. We need automation in all its forms. So, we're attacking one area, which is making important decisions about buildings. Other people are putting robots on construction sites, which is all great. And there's, prefab in factories and all these things. We're all attacking the same problem, which is, how do we scale what humans know up to what humans need?
Okay. So I think with so much of you talking about the technology being open source and still not completely open source, would you like to show me and rest everybody a quick demo of how does this technology look like? And we will get into some details about it, that why, if I have to use Hypar, how do I get to use it?
So let me show you kind of an extreme example of that we find pretty fun. I'll need you to turn on screen sharing for me.
I have.
Okay, let me try again. There we go. All right. 2 seconds. Let's bring this up. So I mentioned Hyperspace earlier. So this is a time lapse of Hyperspace. This is one of our engineers creating an office plan. Now, what you're seeing on the left, opening and closing there, is a whole stack of individual little, what we call functions that are doing different tasks. One of them is laying out each of these rooms. And so, this is something that we have pretty good data on by talking to a lot of firms, that somebody usually takes a week to get to, and our engineer got there in 9 minutes. So this is the kind of thing we want to make possible. There's really no reason that developers should be waiting 6 months on designers for a development project or a set of proposals. We want people to actually concentrate on what's important here, not making sure that, every room has a desk, but that it actually has the right one, or that we've got the right distribution of rooms and the right distribution of areas according to the client's need, for example. Now, this is something that people can use today. I won't promise that you can do it in 9 minutes. Obviously, obviously one of our engineers has spent a lot of time on this. But when we concentrate on this and then given tests by different firms, you can come up with 4 or 5 proposals in a morning. And a typical figure that we hear from them is we can get 3 proposals to a client in 2 weeks. Now, there is a point at which clients are going to realize that it shouldn't take 2 weeks. But on the other hand, there's no reason the firm should have to take 2 weeks on this kind of proposal, because there's so much more to do after this point that why can't we just get to this point where we can bring the client to a decision as quickly as possible where they're satisfied, and we can move on to the important work of saying how we're going to build that thing. If you would like, you want to indulge me in a couple of other examples.
Sure.
I can show you. This is one we're kind of proud of because this kind of shows the promise of Hypar. So what you're seeing on the left in this stack is a set of functions that we just wrote for anybody to use, and then a couple of custom functions that Marco Giuliani wrote to enhance those and create this kind of apartment unit optioneering application. And so he didn't have to write things like how to get the site or how to put levels in it or how to put a facade on it or how to put floors in. He just had to add 2 more things, which was really the important part to set up different options for unit distribution and different envelopes that these units could fill. So this is the real design work. These are decisions that need to be made, not like, where do I put my levels, right? So what we see is the possibility for the industry to stop treating every project as if it's brand new on a blank tabula rasa that they have to fill with their genius. There is a lot of genius out there that should be served, but it's not served by diverting it into mundane tasks, right? Making the decision about what the best distribution of apartments here is, that's a human decision. That's a value system brought into the project that the designer is trying to capture, right? We're never going to capture a complete value system inside a computer program. We always need the humans to decide what's best. And that's what we're trying to give people the tools to do. Give them an opportunity to examine lots of options fast and understand what they mean and make a good decision. And so, we do things like this. I've kind of showed a couple of architectural examples. Things that I can show from actual customers are static, but more complex. So we work with a building product manufacturer on roof drainage systems, and we've worked with them for about a year and a half or so. And this particular type of drainage system is extremely complex from an engineering standpoint because it's siphonic. And so there's a vacuum that has to be maintained, et cetera, et cetera. I never thought moving water off a roof could be this complicated, but it turns out it is. And so what the market condition they were looking at is they saw a 30% like year-on-year growth in logistical buildings in the EU. And they look at, how many engineers they have to design these systems before they get shipped. And then they look at that growth curve and like, well, we're not going to grow our engineering team 30% year on year. Even if we can find the engineers, what do? Well, we have to automate, right? Another firm described themselves as, we build shoe boxes with structure and then we chamfer them sometimes for the site. So this is a warehouse manufacturer. And again, these are types of buildings that are put together by rote, right? They have a speed aisle for the forklift. They have a certain aisle width that's related to the racks on which the goods are going to be. These buildings, of course, are springing up worldwide, especially given the pandemic, where they've been kind of given jet fuel because, everybody's shipping everything now. So this kind of thing, like this is not something that people should have to spend a lot of time on. And, on the other end of the spectrum, we're working with a large construction company, and they had a simple goal. We want to reduce waste on the gypsum wallboard that we use on projects. And here's our usual figure of waste, and we want to cut that almost in half. Can you help us? And so this is where we get into like kind of scaling up the expertise, because this firm has a person who has been doing this for a quarter century and is very good at it. And there's one of him, and he will retire. And so what they're saying is, can you give us kind of a safety net to our younger project managers that they can run a program, find an optimal distribution of this material, and that way they're not constantly having to call this guy to see if it's okay. today who may or may not be available, and we can have confidence that we are working on our material reduction. Now, similarly, in structures, we see people saying, well, can you help me minimize the amount of steel tonnage I use? And of course, we've seen in the last couple of years high volatility in a whole bunch of materials. So of course, everybody's trying to find a way to reduce their material use. And these are the kind of things that computers are very, very good at, and only very experienced humans are good at, right? I think probably a lot of people who listen to this podcast, as I did when I was a young architect, had the experience of, the gray-haired guy that, I am becoming, came by and glanced at your desk. And this is back in the days when we were all drawing on boards, would put his finger on something and say, gonna have a problem there. And he would walk away. It's that kind of like rapid, intuitive understanding people get after decades in the business. That's the kind of thing that we're trying to get people to download their expertise into something so that we can distribute it to younger folks so they can make better decisions too. And there's an interesting precedent for this that I only heard anecdotally, but I did hear often enough that when we moved kind of from 2D into Revit and other 3D environments, that the intuition of young designers was developing far more rapidly than it used to. And so they ordinarily expect somebody to be kind of have this sort of 3D spatial intuition after about 10 years of practice. They were seeing it in like 5 years or less, because people would go out into the field and they would see something and they would say, I shouldn't be able to see that, because they had stood, quote unquote, in the model in that place. And they knew that canopy was 3 feet more over or whatever it is, and they shouldn't be able to see the air intake up there. And so those kind of things that become available just by virtue of working in 3D, we want to take one step farther and make it about that more nitty-gritty, intuitive expertise available to everyone so we can scale it up. Because experts don't know how they do what they do, right? Unless you make them think about it. And so, for example, with this piping customer, at one point we said, okay, so talking to 2 engineers who work there, all right, so how do you decide to do this or that? And we got this 1,000-yard stare from both of them as both of them realized they don't know. And they went off on a 6-week quest, literally, to turn into mathematics the way they do it. And then they had to experiment against past jobs just to make sure that the formulas they had come up with that they thought were correct actually exhibited the same behavior as the decisions they had made in the past. And so this is not falling off the log easy for anybody to get new expertise on the platform. But once it's there, once it becomes more widely available, it's available, right? And we don't necessarily have to constantly recreate it, which is what's happening in our apprenticeship and professional lives. We're constantly recreating this intuition in people. We think that if at least the basics are there and you can give people feedback on whether they've made a good decision or bad, you can start building up that intuition much faster.
Right.
I have a friend in telecommunications, and he, at the extreme end, he describes the process of laying out antennae on a tower. And he says, so this is what happens. The design software comes up with a solution for all the antennae. The engineer moves a couple of antennae around. The software tells him how the engineer made it worse. And then the engineer puts it all back and hits print. And so, it's kind of a bleak existence for that engineer. But that engineer should be working on more complex things, right? And so those people in those firms, rather than be, that kind of software babysitter, essentially, want to get onto complex projects where there is no known solution to the problem. That's what people should be concentrating on, where the known solution isn't available. And we can make the machines take care of the known solutions. If I may, I want to show one more thing that starts to bring that through. So one of the things that is so far unique about Hypar is we're not just about automating everything we do, because that last mile where things are not entirely correct needs to be bridged with human judgment. And this is just a quick video to show. This is a generated structure that we're looking at. And there's a function called structure in kind of straightforwardly inside Hypar, where you can play with this, yourselves. But one of the things that we do that's unique is we also let people edit the results and preserve them through subsequent generation cycles. So people can do things like, generate a layout of rooms, but then intervene and say, no, I don't want that room to be that function or those structural columns to be there. I want them to be over here. I can intervene and start, shoving furniture around the way I want it. But the automated part of this process still is there, and you haven't broken it. And that's something that so far we think is unique on the platform, this ability to, we call overriding, but basically you're intervening into an automated design to make some human adjustments, but you don't explode the rest of the automation and have to start over again. Because one of the phenomenon we also noticed in the industry is we would see people come up with these incredibly elaborate visual programming, Grasshopper or Dynamo, and there'd be, dozens of nodes and hundreds of wires and all this stuff. And it would really work for a project. It would really save time. And then they would, on the next project, start from a blank sheet again and build another, many dozens of nodes, many hundreds of wires thing, because the previous one just needed one adjustment, and it was really, really hard to do without breaking everything, right? And starting again. And a lot of people have had this experience. So this combination of automating something into a sensible solution that then you can intervene for circumstances that only the humans really know about and the algorithm doesn't, that we think is the special sauce here on the platform that really makes it building decision platform, because it combines the best of what automation can give us, but with the safety of human judgment, engineering, design, production methods to make sure that we've accounted for the entire situation.
Okay. So my last question in this is that right now Hypar is integrated with Revit. Are you planning to develop your plugin enough that it can be integrated to other BIM tools too?
You can actually drag and drop Rhino files right into Hypar right now. The most requests we get are to integrate with Revit. We are considering an even deeper integration. If you'll indulge me one more time.
Sure.
And I thought I wasn't going to show this, but I will. Let's get rid of this somehow. Here, let's share. Let's try this one so people can get a feel for some of the integration we do. So those of you who use Revit are very familiar with this house. And what we've done here is we've previously done an export of that model with a Hypar add-in, which is free. And so now we've brought it into the Hypar environment. And there's two more functions here that are doing two things. The first one is panelizing the walls according to a bunch of input parameters. And the second one is actually doing the framing in each one of those panels. Right. So, this is probably, I think this is actually real time. It might be sped up at 1.5 times or something. But what you're saying is like, this is a task that might take somebody a morning to figure this out. And it's done in seconds, right? There's really no reason humans have to sit around figuring out like how we're going to actually frame this panel. What they might want to do is intervene in here, which they could do and change things. But we, have a clear understanding that people start with context coming in from other applications. So we bring in DXFs as well. So people want to use CAD, etc. And we also export Revit models, SVGs, images, blah, blah, blah. So we're well aware that we kind of exist inside an ecosystem of software. We want to make it as easy as possible. So we, like any software company, we sort of respond to substantial requests. And so Revit and AutoCAD have been the most requested. And so that's where we put our energy. But we had several situations where it would make a lot of sense to work with Rhino, and we do.
Let's get to the next section of our discussion, which is impossible questionnaire.
I was looking forward to this one.
Because I have been totally blown away with the philosophy and with everything that you guys were talking about. And I was just feeling like the kid in the room who understands something and who has a lot of questions about some things. However, now I'm going to make you feel like kid in the room. And so I'm going to be asking you some really difficult questions. If you answer that, you're a genius. There is no gift hamper here. But you would earn a lot of respect.
Okay.
Okay. So my first question is, what is the melting point of aluminum?
Believe it or not, I actually used to know this. Is it somewhere around
Okay, you gotta
1700
give me
degrees?
an answer in degrees Celsius, not Fahrenheit.
Oh, Celsius. Oh, God.
Okay, give me a Fahrenheit. I will prefer.
All right, let me try to do a little conversion in my head.
You give me
I
the
don't know.
Celsius. I will.
1500 Celsius?
No, it is 658.
658. Okay.
658 degrees Celsius. Next question that I have is, which of the following sealants may not be used on a floor flange joint?
Okay.
A synthetic rubber gasket, a natural rubber, a silicone compound, or a closet setting compound?
The last one?
No, it's a silicone compound.
Really? And is it fire issue? Because that kind of stuck a little bit in my mind when I was thinking it's got to be fire, and I know rubber's fine.
Yes.
And so
the last question is, how far apart should weep holes be at the bottom of a masonry veneer cavity wall?
I want to say, if we move this into metric, 1.5 meters.
Why are you always double off?
Oh, am I double off?
It's 800 mm, so 0.8.
Okay, yeah.
You're almost double, like you said, 1,000
Yeah,
something.
I'm all about scaling up.
This is almost the end of this podcast. And just before you go, I want you to talk about the rose, bud, and thorn, not just of the platform that Hypar is or the technology behind it, but in general, where our industry is going with automation and with generative design.
Yeah, look, the rose is definitely that we have literally, what are we up to now? 60 years of expertise lying around out there on how to apply computation to AEC problems. Okay. When I first really started looking into generative design around 2010, 2012-ish, I started delving into the academic history of this and was, astonished to find stuff that went all the way back to about 1963, right? And typically academia expects somewhere between 17 and 20 years for something that they produce to actually be commercialized. We're still counting upward in AEC, which is a shame because there's an enormous amount of knowledge just sitting around free in papers that could just be implemented now in software to help people make better decisions. So the rose is that we know really a lot, and a lot of it actually has been reduced down to language that software can understand, which is mathematics, right? So that's the rose. The thorn is, of course, that it's very hard to get that stuff into some usable form. And one of the tasks that we've undertaken at Hypar is to try to make that as easy as we possibly can, because we just look at, what could literally be warehouse upon warehouse full of papers on how to make better buildings. And we want everybody to have access to that, right? And so our way is provide easy means of automation and environment that people can deliver this stuff fast wherever it needs to be. Right. So that's our contribution. Okay. The bud is that I think we're seeing a widespread recognition that the status quo cannot continue to obtain. And frankly, in younger generations than my ex, I think the conviction has grown that we are in a new type of era, and we must rethink, everything from how we put up buildings to how commerce works to whether capitalism is the right thing for people to live together and how our politics work and everything else. So I think we're at a point of, frankly, we have this kind of localized pandemic crisis, but we're also in a sort of longer term and increasingly evident climate crisis. And I think there's a widespread understanding that we have a species-wide problems that we must address as a species. And, we hope to be one, infinitesimally tiny part of helping solve, these types of problems. But, you can't, like the old saying goes, you can't fix anything until you have a problem. And I think there's a widespread recognition now that we have a problem and that we need to figure out how to address it. So to me, that's actually the hopeful thing, that everybody's understanding, sometimes in some terrible visceral way, is, as their homes are destroyed by tornadoes or their crops wither, under a heat wave, that we must address things. And the only way we can do that is collectively.
That is great. I am so glad we were able to talk about Hypar and a lot of other things. I'm totally looking forward to having more discussions around this and getting to know the platform even more. Thank you so much, Anthony.
Thank you. It's been a lot of fun. Appreciate it.